All right, here we go. So this is chapter 22, number 20. I'm going to use the board because it's got a lot of work in it. All right, we don't need that anymore. I'll get rid of that here in a minute.
It's so funny.
All right, so in this problem, there's a square loop of wire and a circular loop of wire, and then I don't remember the rest. So give me just a second to take a look at this again. Chapter 22, number, I keep forgetting, 20. Chapter 22, number 20. All right, so we got a magnetic field perpendicular to the plane of a single turn circular coil. All right, so we've got a loop of wire like that, and we got a magnetic field going in everywhere where that's at, okay? And then it says the magnitude of the field is changing so that an EMF of 0.8 volts is made. So we got an EMF of 0.8 volts. Oh, and I already know that there's enough going on in this problem that I am going to put extra information on the picture so I can keep referencing back and don't mix up my numbers. Does that make sense? Or my variables? Okay? All right, and I'm just going to call that EMF. We're going to just call this EMF 1 for the circle. Okay, so that'll be our EMF 1. Same thing as the voltage. Is that okay? So I can use Ohm's law in conjunction. I mean, Ohm's voltage is also 0.8. Same difference.
Yeah.
Okay? All right. Let me keep reading here. And a current of 3.2 amps. So I'm going to call this my I1 is 3.2 amps. And right away, I'm thinking, oh, great. So I can get R1 if I need it. R1 is something I know because V equals IR. Is that okay?
Yeah.
All right. So I've got resistance 1 as well. I've got the resistance of this wire. I'm sure that'll come into play later. Okay. Then it says the wire is reformed into a single turn square coil, which is used in the same magnetic field. And then we want to know what EMF and current are induced in the square coil. So now we have a square coil. I'm going to draw a line here, square coil. And we want to know what EMF we're going to get and what current we're going to get out of that. Okay. And I already know the resistance of this wire, because if we're breaking it apart and reforming it, the wire's length has stayed the same, the row has stayed the same, the cross-sectional area of the wire has stayed the same, so I know the resistance of the wire if we break it and reform it into a circle. Is that okay?
Yeah.
All right, because I could solve directly for that. So if I can get either one of these, I'm home free, because I can use Ohm's law to relate them. Is that okay? Yeah. Now, the key did this as some giant ratio. We'll see if I end up using a big ratio or not. I'm not sure. We'll see. Let me keep reading, because they seem to have given me a lot of numbers, okay? And something must be changing here. Oh, yeah, the magnetic field. They said the magnetic field is changing. So we have some delta B over T. So there's that. That's the rate of change of our magnetic field, okay? Oh, and I'm not, this goes back to that rate stuff we talked about earlier. Anytime I write a T, you can assume delta T. Okay, all right. So delta B over T, and that is still the same thing over here. So we're just going to have the same thing for both of them. Things that are different, for sure the areas, okay? So we'll call this A1, we'll call this A2, okay? And also the, that might be all that's different. Now let me just make sure that they reformed the same wire into that. Wire is then reformed into a single turn square coil. Oh, and this is supposed to be a square, not a rectangle. I'm just going to write square here, meaning all the sides are the same length, yes? Okay, all right, okay. So now let's go ahead and see if we can find the EMF of, or an equation for the EMF of either one of these that are in this changing magnetic field. All right, so I'm going to try to use the same form that we have on here. So for flux, where is it? Flux, flux, flux. Flux, they use capital Phi, so they got that equals B, I'm changing the order slightly, BA cosine theta, okay, for our flux. And we know we have to have a change in flux over time for us to have an EMF. So something over here has to be changing. We know it's the B that's changing. Is that okay? So now I haven't put the negative on here, so I'm going to go ahead and put absolute value. I'm just finding, there's no implied directions here. Is that okay? If I need the direction of the current in the loop, I'll do my I'll do my my right-hand rules. Is that okay? All right. Also, I don't think we even know if the field's going in or out. I think they just said perpendicular to.
No, I don't think they said.
They'd said that. So this is me making it slightly more specific just for the visual, okay? So I can get rid of this because we already know that the direction of the area will be parallel to the field, which means cosine of 0 is 1. Is that okay?
Yep.
All right. And are you still okay with this delta B over T? Because that's the thing that's changing.
Yep.
So right now we have a general expression here for our EMF for either one of these, it should be delta B over T times A. And that should be it for the EMF, for the voltage of either one of these. Is that okay?
Yeah.
All right. So now, I think I'll go ahead and do a ratio, mainly because I don't know delta B over T. So I'm assuming when I do a ratio of the EMFs, I'm assuming correctly, that will cancel out. Is that okay?
Yeah.
All right. So let me go ahead and do that. So this was just a general result. That would always be true if we had something where the area was staying the same and it's the magnetic field that's changing and stuff's perpendicular. So when I say general to both of these cases. Is that okay?
Yeah.
All right. So now let me go ahead and do a ratio since I have two cases. Let's do EMF1 over EMF2. And if I can get a number here, right, for EMF2, I said I'm home free. So if I can answer this ratio, since I know 0.8, okay, and if I can get what these two are equal to, I'll be able to solve for E2, and then I can get the other stuff. Does that make sense?
Yeah.
All right, so let's go ahead and do this. So EMF1 will be this delta B over T times my area 1 over delta B over T times my area 2. And sure enough, the delta B over T stuff goes away. Is that okay?
Yeah.
All right, so now I'm down to the areas. So now we've got an area of a circle, area of a square, but we've got a problem. I'm going to go ahead and substitute in just based on geometry, but I don't think they told me R in terms of L or anything like that in the problem, did they? No? So I think we're going to end up using this idea with our rho L over A stuff. We'll see. I don't know. We'll find out here in a minute. Or no, maybe we're going to use circumference. We'll figure it out here in a minute. Okay, so the area of a circle, just starting with that, is pi r squared, okay? And our area here, I'm going to go ahead and add on here some variables. So I'm just calling that r. And let's just call this, I don't think I want to call that. I'm going to call this lowercase l. Are you okay with that? Just in case I use any of our equations from our equation sheet that have capital L for length of the wire. I don't know if I'm going to do that or not. Are you okay with this being lowercase l?
Yeah.
Yep, all right, okay. I'm just going to call that L, so we'll have that as L squared. Yes? Okay, so there's our two areas. And now I'm definitely stuck, and I don't think I actually need any physics equations. I think I need the idea that we broke this wire apart and reformed it here. So the lengths, it is that idea I talked about before, just without the physics. The length of these two wires have to be the
Same.
Is that okay?
Yeah.
All right, so it's that idea. So what's the length of my circle? It's going to be 2 pi r. Has to equal, my length here will just be L plus L plus L, so 4L. Is that okay?
Yeah.
So it wasn't the physics one, so I could have used capital L and I would have been just fine. Is that all right? I was just trying to make sure I had a different variable in case I needed it.
Yeah.
Are you all right still with the, okay. All right, so I'm going to pause here for a minute before I do some additional substitution. I'm going to call this box 1, where I found the general equation, box 2, where I started doing my ratio, and then box 3 will be right here with the lengths. Where do you guys have questions? We're not done yet. I am going to substitute the stuff. Yeah, we got plenty of time. Just tell me which box you want re-explained. And this is definitely a problem, by the way. If you just like, if you've got the mindset, I think you're probably already broken of this habit. But if you're like trying to see the whole problem before you solve it, yeah, if you really spend some time carefully thinking and you've done a lot of stuff with this, you might see it all. But I doubt it. I didn't see it all until I got right here. Like I wasn't sure how we were going to get rid of the L, but yeah, that makes sense. So don't just start getting organized when you get one of these problems where you can't see exactly what to do. Start separating it out, add stuff to the picture, and go from there. Questions on 1, 2, or 3? Box 1, 2, or 3? All right, I'll leave the numbers up there so we can ask about them later. So now let's go ahead and substitute. I'm going to go ahead and just solve this for, I don't care. I'm going to solve this for L. So L is just going to be, pi r over L. 2 divided by 4 is a half, so put a 2 down there. Is that okay for L in terms of R? 2/4, 1/2 pi r. No, wait. Hey, wait a minute. No, that's not right. What did I just do there? This should be L. Why is there an L down here? I have no idea what I just did. Okay, so I'm going to divide both sides by 4. That's it. Yes, are we okay? Yeah. Pi r over 2?
Yeah.
I don't know. I have no idea. I'll blame. No, I can't really. It's not first block. I can't blame it on the caffeine. But where is the 2 liter? Yeah, I haven't had too much. But sorry. All right, that's no excuse. I got a good night's sleep. That was just me being stupid. Are we all right with that?
Yeah.
Everybody else okay with that? Just had a crosswire. Okay, so now let's go ahead and plug in up here. So I'll have pi r squared. So I'm going to extend this out. So we're going to have pi r squared over my L, but I got to square everything. So I'm going to have pi r over 2 squared like that. Is that okay? Whenever you substitute, put parentheses and then square it.
Yeah.
Yes? Who's drumline today? Girls swim. Is there anybody that needs to go out there? Just go ahead, just go in front of the, go behind the camera if you need to go out there. Okay, all right. So pi r squared. So now the r, since it's squared, will cancel, but I can't get rid of the pi. Really? Okay, I guess I can. Okay, all right. So now we're going to get pi over pi squared. We'll have a 2 squared down here. That'll come up top, so that's a 4. So now I can cancel one of the pi's. So I'll end up, if I did my algebra right, 4 over pi. And someone's freaking out right now because I've said make sure you have decimals. I'm not at my final answer yet. Do we understand? I'm just doing a ratio. I haven't connected back to the real world. Yes? Are we good? Okay. So I will get that as a decimal before I calculate my E2. Okay? All right. Or I mean, when I get my answer for E2, I won't leave pi in the answer. Is that okay?
Yeah.
All right. So now let's go ahead and go back here. This was E1 over E2. And we knew what E1 was. So I'm using this equals 4 over pi. So E1 is 0.8 volts over my EMF2. I shouldn't call that an E. It's not an E. But EMF2. Is that okay? All right. It's an epsilon, right? Okay. I think. Equals 4 over pi. So now we should be able to solve for that EMF2. Let me grab a calculator. Are you still with me on the algebra?
Yeah.
Is everybody else okay? I took this equals 4 pi, and I'm plugging into that now. I'm just plugging in that EMF. Okay. So we got 0.8 times, I'm just going to call it 3.14, divided by 4, and then the inverse of that. And I'm getting about 1.6 volts. All right. Now, I have no idea if that's right, but I do have the key here somewhere. Oh, no! It's not 1.6. It's supposed to be 0.63. Ah, what did I do wrong? Let's hear. I took the inverse twice. Did I? Let's find out. Let me just double check here that I had EMF1 over EMF2. EMF1 is 0.8. So 0.8 times 3.14 divided by 4. Oh, yeah, I did, didn't I? Yeah, because I cross-multiplied. I don't usually cross-multiply. That was the problem. Yeah, I did take the inverse twice. Good job. 0.63 volts, approximately. And 0.63 is what the key got. Is that okay?
Yeah.
Yeah, if I cross-multiplied, I didn't have to take the inverse. Normally what I just do 4 over pi times, or sorry, divided by 0.8, then take the inverse. I went and cross-multiplied, so I didn't have to do that. So we're good? We good, everybody? Yes, yes, yes. Okay, so now I know this is 0.63 volts. And back here, I can calculate my resistance. Same resistance over here, I can solve for I2. Do you think you're all right with that?
Yeah.
Go ahead and take a calculator. We still have 10 minutes, okay? So go ahead and take a calculator, solve for R, and then work out what I is, and you should get, if you don't, let me know, because I'm going to do it up here. You should get 2.5 amps for this when you solve. It should work out to that. But you're really just doing Ohm's law twice, right? So it should be that hard.
Yeah, it worked out.
It worked out? Okay. Does anybody want to see the Ohm's law twice? V equals I R to get R. Use the same R because it's the same wire, just reformed. Solve for I using that voltage. Does that go with everybody? That did not take nearly as long as I thought. I guess that's a good thing. All right. Or I went way too fast. Are you okay? 100% okay.
Yeah.
Who's got questions? Anywhere up here. I've got a lot of it numbered. If it's somewhere in the original picture, let me know. Or if it's the math, let me know. By the way, on the AP test, they love to have wires that they reform into other wires. But watch out. If they say they melt it down, that means when they reform it, they could change the cross-sectional area and the length. Does that make sense? Then you are using, if they start melting the wire down and changing the cross-sectional area, then you are going to start to use stuff like this in your problem. Does that make sense? Okay. All right. But not for this one. I thought we were going to end up using that. We didn't. Questions? Going once? Going twice?